All right, it's Monday. Ready for a new video? I'm not. To be perfectly honest, I'm pretty much over all this stuff. I'm ready to be back in my classroom, but I know that's not going to happen. But anyway, so I'm going a little crazy. I'm a little tired of it, but that's okay. Today we're going to do color coordinates. Polar coordinates part 1. Okay, so this is going to be broken into 2 parts. It's kind of long. All right, so first of all, a polar coordinate plane looks like this. Kind of looks like the unit circle almost. Only notice on the unit circle, you just have one ring, okay, because your radius is 1. I know it's a big one, but it's just 1. But on the polar coordinate plane, you have more than one ring. This ring would be at 1. This ring would be at 2. 3, 4, 5, and so on. Okay, so this is what a polar coordinate plane looks like. Now, how do we use that? So, what we would normally call the origin is called the pole. So this point right here in the middle is called the pole. All right, and our ordered pairs, instead of being XY like they are on a regular coordinate plane, our ordered pairs are R stands for radius, R for radius, and theta. Theta standing for the angle. Okay, so over here, R would be for radius. So let's say your R in your coordinate plane was 3. And your theta was 30. That means you would go to 30 degrees and you would go out 1, 2, 3. So 330 would be right here. Okay, so let me show you that on the little picture I got here. So first of all, your angle is in standard position. Okay, so let's say this is your X and your Y axis kind of. Okay, your angle has one side that's on the axis right there, on 0 degrees. Okay, that's called standard position. All right, and then the other side of the angle is out here at an angle, like say 60 degrees. Okay, and then you have these hash marks on the 60 degrees. All right, so if you're at 360, that would be out 1, 2, 3 on 60 degree angle. So that's 360. Okay, so 360 on here would be go to 60 degrees, which is right here. Go 1, 2, 3. 360 would be right there. All right, so this is the x-axis, or this part right here. 0 degrees is called the polar axis. Can't spell today. All right, it doesn't go all the way across. It's not this part over here. It's just from 0, or the pole, out 0 degrees. That's your polar axis, and that's where we start. So why would we use this? I don't know if you've ever noticed, like on a radar on the news, their line goes around and updates your radar. So it goes like this. Like if it was on here, it goes, and their line goes around. And updates your radar. So it's on a polar coordinate plane. The radar on TV is on a polar coordinate plane. Okay. A lot of things for satellites and all that, they're on a 360 degree rotation. So they're on a polar coordinate plane. They talk about coordinates of degrees and how many knots you're out. So for example, also like in the military, if you're on a radar, okay, and this is you, and so you got a ship coming in here, okay, then you're going to show up on their radar, and they're going to say, he is from us, he's about, 5 miles out at 45 degrees. That's polar coordinates, okay? So anyway, that's how they might use these. So let's look at an example where we're going to graph one. So you can draw your own. You don't have to draw this extensive thing every time. You can just draw this. All right. So we're going to graph 2 230. All right, so what that means is we're going to draw our coordinate plane, kind of like just the x and the y-axis, but our pole is over here. And then 30 degrees, remember 45 is half, so 30 degrees would be about right here. Okay, and then put you some hash marks on that to represent your numbers or your circles. And we're going to go out, here's 30 degrees, and we're going to go out 1, 2. So 230 would be right there. Okay, pretty easy lemon squeezy. All right, so I've pre-drawn some graphs on here to do some other examples. But there are some different things, different ways to write these, okay? So both theta and r can be negative. All right, so let's look at what happens if r is negative. All right, if r is negative, you go out to that angle, and then instead of going out to r, go out to that angle. Let's start a right angle again. You'll go straight back. R units. Okay, so let me show you what that means right here. So let's say that my ordered pair is negative 360. All right, so if my ordered pair is negative 360, I'm going to go 60 degrees. And instead of going to positive 3 or out to 3, I'm going to go straight back. So look, I'm going to go out to 60 degrees, which is right here. And then instead of going 1, 2, 3, being here, I'm going to go straight back 1, 2, 3. So negative 360 would be right here. Okay, so you would use the angle that goes straight back. That's why I have all of these marked, so you can see that. Okay, so notice, just a little clue here. So this is negative 360. I went to 60. I went straight back 3. Okay, so that's negative 3, 60 degrees. Notice that the coordinates for that could also be 240 and out 3. So the coordinates of it could also be 3, 240. Oh, I got tape there because my coordinate plane, but anyway, so those coordinates could also be that. So there's more than one ordered pair for any kind of coordinate on this graph, and we're going to look at how to find some of those. Okay, so notice that, just keep that in mind. All right, so what if theta is negative? I got a different graph for this. Okay, so theta is negative. Instead of going my positive direction for my positive angles, all of these are positive because I'm going counterclockwise is positive. So if I have a negative theta, instead of going positive, I'll go negative. So positive 330 would end up being negative 30, negative 45, negative 60, negative 90. I'm going to go counterclockwise. Okay, so if theta is negative, you go counterclockwise. You go clockwise. To that angle. I just tried to write all those words together. Thangle. All right, now sometimes it gets confusing because, like, if you're over here, maybe you don't know this is, negative whatever. Okay, so what I do is, let's finish marking this right quick. This is 120, 135, 150, 210, 225, and 240. Okay, so what I do is, look, when I'm doing negative angles to try to help me, so if say I want negative 135, so negative 135 is 1, 2, 3, 4, 5, 6 marks in the positive direction. So negative 135 would be 1, 2, 3, 4, 5, 6 marks in the negative direction. So this would be negative 135. Okay, if I want positive 45 is 1, 2 marks in the positive direction. So I go 1, 2 in the negative direction. And that works because I have all my common angles on here. Now for other angles like that are not common, you know, like 20 degrees or something, you would just have to go the other direction 20 degrees. You would have to just count it out, all right? So for negative theta, you're going to go the negative direction. So let's look at an example here. Let's say I'm going to go to negative 60. Okay, so the ordered pairs for polar coordinates are kind of strange because we do the theta first and it's written second. But that's just how it is, okay? The degrees is second, but we use the degrees first. So we're going to go to negative 60. Look, positive 60 is 1, 2, 3 marks. So negative 60 will be 1, 2, 3 marks. So we're on this line right here. And we're going to go out 2. So that would be right there. 1, 2, negative, oh, sorry. Positive 2, negative 60. That would be where that would be, okay? Also, notice that could be 300 degrees and positive 2. So that's another coordinate that it could be, okay? 2, 300. Those would be equal. Those would be the same coordinates. All right? So that's how you do negatives. That's what happens if your theta or your r is negative. Now, we are not really used to, first, before I get into that. So, what I pointed out on both of those examples that you can have other coordinates that are exactly at that point also. So, we're going to look at ways to find those other coordinates. So, in general, we have a formula. This might look familiar to you. Negative r theta is the same thing as positive r theta plus or minus 180 degrees. Okay, so in the normal coordinate plane, Descartes' coordinate plane, the linear coordinate plane, in the normal xy coordinate plane that we use, there is one and only one point or coordinate for a point. But in the polar coordinate plane, there are infinitely many ordered pairs for a point. Okay, let's look at an example here. So let's say I have the ordered pair 2, 30 degrees. All right, I am going to use my formula up there, and I'm going to find, oh, no, I'm going to give you a new formula. I'm going to find 3 ordered pairs that have the same point as this. Find 3 other ordered pairs for this point. Okay, all right, so we're going to, first of all, I'm going to give you the formula. So the formula looks like this. It's r and then theta plus n times 360. Does that sound familiar? We put the n on the end this time because we're actually going to use it in math. Okay, so this was familiar. Remember when we had to cover for our infinite solutions? We had to use that. So we'd say 45 plus 360 times n. So that's the same formula. We're going back to that. We're using that again. So here is it in radians, just in case you want to use radians. Okay, so this is our formula. So So let's look at this. So let's go ahead and graph 2, 30. So here's 30 degrees right here. And then this would be 210, okay? Just off of my graph that I already have done. And then I would have 1 unit, 2 unit, and you could go out on that. So 230 would be right here. All right, now, couldn't I also have done 210 and then went back 2? Do you see that? I could have went all the way to 210 and then went back 2 units. So this coordinate could also be 210, -2. You with me? Then I could have went this way. Could have went the negative direction. This would be -150. Okay, so I could have went the negative direction, went -150, and then also did -2. So I could have that. So what this formula does, allows us to actually do this work and find all the points without having to draw all these graphs. Okay, so for example, if I did 2, my R is 2, and then I could have did 30 plus 360 times 1. All right, I could have just did 30, that would have been 1, but made another one by doing 30 plus 360. So another ordered pair where this would be 2 and 390. 390 means I would go all the way around 360, then 30 more, and then out 2. Okay, let me do that again. All the way around, that's 360, then 30 more, then out to 2. So see, that's another ordered pair that I could have used. Now, to get a negative, I could have done 230 plus 360 times -1. So, let me use my calculator, my handy dandy calculator for this one, because you know I'm not even awake, so I don't have any idea what this is in my head. I'm just kidding, I'm awake. -330. Okay, so I could have went all the way around -330. That would take me back here the other direction. Whoops, sorry. All the way around -330 would take me back to here the other direction and then out 2. So there's another coordinate. Now I could plug in a 2 for my n. I could plug in a -2. I could plug in any number I want for 360 for n, and I would get another coordinate that would be equal. Okay, now on the -r ones, if you want to change r to negative, you're just going to have to use the angle that's across. So if I wanted to change r to -2, okay, then I would have to use 210. I would have to use the angle that's across from 30. So you could definitely change r to -2, but use 210, you'd have to use the angle across from it. All right? All right, so let's look at our last example for today. I'm sorry, I know this one's been long. I told y'all it's even broken into 2 parts, so it's that long. Let's name full, plus I talk a lot about stupid stuff. All right, so if I want 4 more points, I'm going to use my formula, r theta plus 360 times n. And again, n is going to be anything you want it to be. Okay, you can do 1 or 2 or 3. And what that n really is, it's the number of rotations you're going to go around. Okay, look back at this paper. If n is 1, okay, you're going to go all the way around 360 degrees and then 30 more. Okay, if n is 2, you're going to go 360, whatever the next one is, 720, and then 30 more. Okay, so that's the number of rotations that you go around, and that's going to give you new coordinates for that angle every time. Okay, so let's look. So first of all, we're going to say 5, and we're going to do our angle, which is 135. And we'll just let the number of rotations be a 1. So I get 5. I'm going to use my calculator. Okay, 130, whoops, 5. I'm going to leave this in my calculator because I'm going to come back to it. 495. So there's one coordinate. And then I'm going to let it be a 2. So look, I'm going to leave that in my calculator. I'm going to scroll back up here and delete that out and let my n be a 2. So I get 855. So another coordinate is 5, 8, 55. And then I'm going to let it be a negative. That way I get a negative angle. Whoops. So scroll back up in here and let it be -1. So then I get -225. So then it's 5, -225. Okay? And then a -1 could be -5, and then across from 135, is 315. So I could say -5, 315. So there's 4 angles that you can use that are other coordinates for that same exact point. Okay, so this is what you're going to be doing today. You are going to be finding different coordinates for the points, and you're going to be using this formula right here. Okay, very important. And then this graph. All right, and again, you don't have to draw the whole graph. You can just draw the little angle part of it. All right, do the best you can. Love y'all. Talk to you later.